Okay, welcome back, Mariam. Now we are going to complete the lessons that we started about the types of mixture, but first, please listen to this video. Okay, Mariam? Okay.
Okay.
Mixtures. Matter present in our surrounding can be classified as pure substances and mixtures.
So first, matter can be classified into two types. Matter, pure substance, and mixture. Okay, it's the first.
A mixture is a combination of two or more substances which are not chemically the same and do not chemically react together.
The first, that mixture consists of two substances or more, but they don't react with each other. Don't react with each other. And it's the difference between mixture and compound. Compound consists of two or more substances that react with each other, forming a new substance with new properties that differ from the component of its component. Okay, but mixture consists of two or more substances, but they mix together, not react with each other, so they can be separated easily by physical means. Right, Mariam?
Yes.
A mixture has the same properties as that of its component elements and can be separated by physical means. In a mixture of sugar and sand, even if we increase the volume of sugar or sand, the mixture remains the same. So it implies that in a mixture, the components can be present in any proportions. When we dissolve common salt in a glass of water, we will obtain salt solution. Similarly, put some mud in a glass containing water and stir it well. We will obtain a mixture with the solid particles of mud dispersed in water. By carefully observing, you will find that in common salt solution, no salt particles settle down to the bottom of the glass. But in the glass containing muddy water, some solid particles settle down to the bottom of the glass. This explains that mixtures have different compositions.
So mixture have different composition according to its component. So we can explain that the two types of mixture are homogeneous mixture and heterogeneous or non-homogeneous. Homogeneous mixture, what's meant by homogeneous mixture, Mariam, according to this activity? What's meant by homogeneous mixture? Yes,
That has two or more substance.
yes. We
And
can, we
can
can
be
or we can't
differentiate.
distinguish between its component.
Yes.
Can or can't.
We can't find the difference between its
Right.
components.
We can't distinguish between its component as as sugar and water or salt and water. While muddy
Yes.
water is called as heterogeneous mixture, that
Okay.
we can distinguish easily between its component, okay, as muddy water or sand and water, right?
Right.
Accordingly, mixtures can be classified as homogeneous and heterogeneous. A homogeneous mixture has the same uniform appearance and composition throughout. Many homogeneous mixtures are commonly referred to as solutions. A solution is a mixture of two or more substances in a single phase.
So the meaning of solution. Solution is homogeneous mixture, okay? Solution is homogeneous mixture.
The substance in the largest amount is called solvent and the substance in the smallest amount is called solute. Now, consider the case of the common salt solution we have prepared. Here, water is the solvent and salt is the solute. Homogeneous solutions are classified as different types based on the solvent and the solute. 1. Liquid in liquid solution. 2. Solid in liquid solution. 3. Gas in liquid solution.
So homogeneous mixture consists of two substance. Solution consists of two substances, which are what and what? Which are either solvent or solute. Okay, either solvent or solute. What's the difference between solvent and solute? Solvent, substance that can be found with large amount as water, while solute, substance that can be found with a small amount as sugar or salt. Okay, Mariam? So it's
Okay.
difference between solvent and solute, the component of solution. Solvent, large substance, okay, but solute, small substance in its amount.
In a solution of vinegar in water, both the solvent and solute are liquids. Hence, it is a liquid in liquid solution. In the case of common salt solution, it is a solid in liquid solution. The best example of gas in liquid solution is soda water. Soda water contains carbon dioxide gas. Let's understand heterogeneous solutions. Suspensions and colloids are heterogeneous mixtures. A suspension is a mixture of large particles. The size of the particles in a suspension is of the order of 10 to the power of -5 centimeters or larger. In a suspension, the solute particles do not dissolve, but they are suspended throughout the solvent. The muddy water which we prepared is a suspension. Colloids are also heterogeneous mixtures, but they appear like a homogeneous mixture. Milk is a good example of colloids. The particle size in colloids is smaller than 10 to the power of -5 centimeters.
So it's the properties of colloids and suspension. There are types of heterogeneous mixture, colloids and suspension, and it explains the component of each of them and the size of its particles.
In colloids, the particles are uniformly distributed throughout the solution. Colloidal particles cannot be seen with the naked eye because of their small size, but their presence can be observed with the help of an ultramicroscope or an electron microscope.
So component of colloids can't be seen by naked eye. Can't be seen by naked eye, but we can see it by electronic microscope because they are very, very small particles, right?
What is the effect of light in homogeneous and heterogeneous mixtures? Let us understand how light affects a colloidal solution. When egg albumin is taken in a glass beaker and some water is added to it, we get a colloidal solution of egg albumin. If we were to shine a beam of light from a torch through the beaker, the light is scattered by the colloidal particles and the path of light can therefore be observed. The light scattering effect shown by particles in a colloid was first explained by the British physicist John Tyndall. The effect is known as the Tyndall effect. In the case of a suspension, light does not pass through it. In a true solution of salt in water, we will not see the path of light as there is little scattering of light. Things to remember. Mixtures are composed of variable proportions of different substances without chemical bonding and have the same properties as that of its component elements. Homogeneous mixtures have the same uniform composition and appearance throughout, whereas heterogeneous mixtures consist of visibly different substances or phases. A solution is a homogeneous mixture of two or more substances, and the substance present in the largest amount is called solvent, and that present in the smallest amount is called the solute. Suspensions are a heterogeneous mixture of large particles on the order of 10 to the power of -5, in which the solute particles are suspended throughout the solvent. Colloids are heterogeneous mixtures in which the particles are uniformly distributed throughout the solution and the particle size is smaller than 10 to the power of -5 centimeters. The light scattering effect shown by particles in a colloid is known as Tyndall effect.
Okay, right, Mariam? Do you understand?
Yes, I understand.
Yeah, any problem till now?
No.
Okay, so let's begin to this part about solubility. What's meant by solubility? Please try to read. Try to read, Mariam.
Solubility, the ability of a solute to dissolve in solvent, or the ability of solvent to make solute dissolve in it.
Yeah, so it's solubility process, the ability of a solute, to dissolve in solvent, or the ability of solvent to make solute dissolve in it, as salt and water or sugar and water. Okay, so solubility, it's what is the mass of solute. We can define it as mass of solute dissolving in 100 grams of solvent at certain temperature. So solubility, the mass of solute dissolving in 100 grams of solvent at certain temperature. What's meant by solubility?
The mass of solute dissolving in 100 grams of solvent at certain temperature.
Right. What are the factors affecting solubility?
The nature of solvent or solute and the temperature.
Yes, right. As when dissolving 36.8 grams of sodium chloride in water at temperature of 25 Celsius, solvent becomes saturated. Okay. What's meant by, I think, saturated and non-saturated and oversaturated and unsaturated must be taken in the previous year, I think. But I think it's from the part which was cancelled, right? Do you know the difference between saturated, unsaturated, and oversaturated solution?
No, we didn't take it last year. It was cancelled.
Okay. Yeah, it's cancelled. Okay, I think that. So we are going to remember this part. In saturated solution, no additional amount of solute can dissolve in them. It's called saturated. Okay, saturated between unsaturated and oversaturated. As saturated solution, no additional amount of solute can dissolve in them. As if you make solution of sugar and water, then you add water, then mix stirring, water, then mix stirring and sugar. So sugar will disappear totally in this water, but in a certain time, okay, when you add some sugar, then make dissolve, the sugar will precipitate in the bottom, right? The sugar doesn't disappear. So it's called saturated. Do you understand me? It's called saturated. Yes, no, no.
You can't add anything to it.
Yeah. Doesn't need anything. Doesn't need any large amount. As no additional amounts of solutes can dissolve in them. Why? Because the ions of the additional amount replace the ions bonded to water molecules. Therefore, these ions precipitate in the form of crystalline solid substance in solution. So, saturated solution is in a state of dynamic equilibrium because the rate of dissolving is equal to that of precipitation. Do you understand me?
This part, no. I don't understand the equilibrium.
Last one, last paragraph.
No, the one that a saturated solution is in a dynamic equilibrium because the rate of dissolving.
Yeah. So it's the last paragraph. Saturated solution in a state of dynamic equilibrium, as in equilibrium state, that rate of dissolving equal to that of precipitation, means that if you add any large amount of solute, will precipitate, not dissolve in solvent.
Okay.
Not dissolve in solvent. Okay, it's called saturated solution. So solution can be classified according to saturation into, try to read Mariam, difference between unsaturated, saturated, and super saturated solution.
Okay, unsaturated solutions that allow additional amount of solute to dissolve in them at certain temperature. Saturated
it needs more amount of sugar. Okay, we are going to take this example as main example. Sugar and water. If you add some amount of sugar to water, then mixturing, so sugar will dissolve in water. Okay, so it's called unsaturated, because by adding extra amount of sugar will dissolve also. So it's called unsaturated. So what about saturated? Yes, complete.
Solutions that doesn't allow the dissolution of any additional amount of solute without a change in temperature.
Right, so it's called saturated, but it's very important to note that without change in temperature, it means that what? It means that what happens if you change temperature? The extra sugar will dissolve or not?
It will dissolve.
Right. So saturated solution that doesn't allow the dissolution of any additional amount of solute without change in temperature. Without. But if you make a change in temperature, so the extra amount of sugar will dissolve. So it's called what? Super saturated solution. So what's meant by super?
Solutions that allow the dissolution of additional amount of solute when heating.
Yes, when heating is the main condition, right?
Right.
As when super saturated, okay, when super saturated solution cool down, what happens? The ions. Yes.
The ions of the additional amount of solute get separated and precipitates in the form of crystalline solid substance.
Crystalline solid substance, yes. So if you make cool down for supersaturated solution, the ions of additional amount will precipitate as in the form of crystalline solid substance. So solubility of most solid substance increases by the increase of the temperature of solvent, right? As for example, the solubility of sodium chloride increase to 41 gram at temperature of 80 Celsius. Okay, solubility of sodium chloride also at 25 equal 36.8 gram. So solubility of sodium chloride at 25 Celsius is 36.8 gram. But if you increased the temperature into 80, so the amount of sodium chloride that will dissolve, it will be 41 gram, as it will increase as increasing temperature. So there is a direct relation between temperature and solubility process, right?
Right.
Okay, so try to read this paragraph from when?
Okay. When supersaturated solutions cool down, the ions of the additional amount of solute get separated and precipitates in the form of crystalline solid substance.
Yes.
The solubility of most solid substance increased by the increase of temperature of solvent. For example, the solubility of sodium chloride increased to 41 gram at temperature of 80 Celsius. The solubility of sodium chloride at 25 Celsius is 36.8 gram.
Yes, right. So this is called solubility. Thermal changes associated with the solution. There are some thermal changes associated with the solution process. So formation of solution process sometimes cause a change in temperature, right? Sometimes
Right.
change in temperature as endothermic solution. There are two types of solution, which are endothermic solution and an exothermic solution. Endothermic and exothermic. What about difference between them? Endo means what? Endo means it absorbs energy. So this chemical reaction must absorb large amount of energy to begin. To begin, it's from condition. It's from its condition that it must absorb some amount or large amount of energy. So it's called endothermic reaction. So it's called solution which absorb energy or heat when they are formed. Example, when dissolving potassium iodide, Ki, in water, it absorbs energy. And the glass container of Ki solution cools down. Cools down. Why cools down? Because it absorbs energy. So it cools down. While exothermic reaction or exothermic solution which give away energy from its name, exo. So it will produce energy as one of its product. So solution which give away energy or heat when they are formed. Example, when dissolving sodium hydroxide NaOH in water, it gives away large amount of energy. Okay, Mariam?
Okay.
Okay, try to read the difference between endothermic and exothermic solution.
Endothermic solutions are solutions which absorb energy or heat when they are formed. Example, when dissolving potassium iodide in water, it absorbs energy, the glass container of Ki solution, and cools down. Exothermic solutions which give away energy heat when they are formed. Example, when dissolving NaOH in water, it gives away energy or heat.
Right. The concentration of solution. What's meant by concentration of solution? Okay. Concentration, it's according to problems about how can we get concentration, either percent concentration or molarity or molality. Molarity, molality. And we are going to know the difference between them. In order to calculate the concentration of solution, we should calculate the concentration of the substance forming them. It's said that a solution is concentrated if the quantity of solute is greater than usual, but not greater than the quantity of solvent, right? So it's difference between concentrated and diluted solution. Okay, as if you have 100 gram of water, okay, so if you dissolve it 10 grams of sugar in water, and in another cup you will dissolve 50 grams of sugar in water, which cup will be concentrated and which will be diluted?
I don't understand.
Okay, if you get two cups, each of them has 1 liter of water, right? 1 liter.
Okay.
In the first cup, you add 20 grams of sugar, then mix stirring. And in the second cup, you will add 50 grams of sugar, then mix stirring. Which cups will be concentrated than the other?
The second one,
Yeah, second one. Why?
because it contains more sugar grams.
Yes, so by increasing amount of solute in a certain amount of solvent, the solution will be concentrated.
Okay.
right? And the methods
Right.
of calculation of concentration of solution will be percent concentration, molarity, and molality. Okay,
Okay.
let's go, okay, to another source to know the difference between concentration of solution. Try to listen, please, Mariam.
Okay.
Solution concentration. If you make coffee or tea, you've probably experimented with the strength of the brew. What makes a mug of tea stronger? Using more tea in the same volume of water results in a stronger, darker drink. In terms of concentration, this stronger tea is more concentrated than a mug of tea brewed with the same volume of water but less tea. In general, a concentrated solution contains a large amount of solute in a given volume, while a dilute solution contains a small amount of solute. Use the slider to adjust the concentration of the tea. Credit.
Okay, so listen to this video or this shape. What happens to this lesson? Observe, Mariam. Observe the color, this.
It's getting darker.
What happened to its color?
It gets it's getting darker, more red.
Okay, Mariam, what happens to its color?
It gets darker.
Yeah, it gets darker. Why it gets darker? Because it will be concentrated as the molecules of tea particles will dissolve, okay, more than the first one. This is the first one. This is the first. Okay, it will be lighter. Then, so it will be concentrated and darker.
Okay.
Right? Okay. So, about defining concentration. What's meant by concentration? What is meant by concentration? Defining concentration. It's the meaning of concentration. Try to read what's meant by concentration, Mariam.
Okay. The concentration of a solution is a matter of how much a solute is dissolved in a specific amount of solvent or solutions. Concentration
Yes,
can be described.
right. This is the meaning of concentration. Concentration of a solution is a measure. This is meaning of this concentration. Okay, this is the meaning of this. Okay, as concentration of solution is a measure of how much solute is dissolved in a specific amount of solvent or solution, right? So,
Right.
what about the concentration rules that you are going to calculate all this? Okay, percent by mass, percent by volume, molarity, and molality. Okay, then mole fraction. First, percent by mass. Percent by mass. How can we get concentration of solute by its mass? It equals to mass of solute divided by mass of solution times 100. But this mass of solution, okay, take care.
Okay.
Mass of solution, okay, means that It's a mass of solvent plus solute.
The whole mass.
Right?
Right.
This is according to mass. But according to volume, volume of solute divided by volume of solution times 100. Also, volume of solution means that it's a volume of solvent plus solute. Right?
Okay.
Molarity equal what molarity?
Moles of solute over liter of solution.
Yes, moles of solute divided liter of solution. While molality?
Moles of solute over kilogram of solvent.
Yes. So what's the difference between molarity and molality?
The molarity is the moles of solute over the liter of solution.
So
while
molarity depend on the liter volume. Molarity depend on the volume of solution, liter.
Yes.
Okay. But
Yes.
molality depend on the mass of solution as kilogram of solvent. Right?
Right.
So it's a very important table. Okay, it's a very important table. Okay, that this table, okay, this table classify and explain the difference between this. Okay?
Okay.
Right. So after that, to explain percent by mass.
Okay.
Listen.
Okay.
Percent by Massachusetts. The percent by mass is the ratio of the solute's mass to the solution's mass expressed as a percent. The mass of the solution equals the sum of the masses of the solute and the solvent. Percent by Massachusetts.
So equal percent by mass, mass of solute, divided by mass of solution times 100. Right? So this is problem.
Right.
Try to read this problem.
Okay. In order to maintain a sodium chloride concentration similar to ocean water, an aquarium must contain 3.6 sodium chloride per 100 gram of water. What is the percent by mass of NaCl in the
Yes.
solution?
So to solve any problem, Mariam, we must know these two parts, known and unknown. We must determine the two parts, known and unknown. Known, mass of solute, which equals what? Mass of solute. Yeah,
3.6.
3.6 gram per NaCl. So it's a mass of solute. Okay? And
Okay.
mass of solvent. Mass of solvent equal what?
100 gram.
100 gram of water. So it's mass of solvent. 100 gram of water. So we have mass of solute and mass of solvent. Okay? But we have
Okay.
no mass of solution. Right?
Mass of solution equal mass of solvent plus mass of solute.
Right. So what's unknown?
The percent by mass.
Okay, so first we are going to find mass of solution equal grams of solute plus grams of solvent. 3.6 gram plus 100 gram equal 103.6 gram. So percent by mass, as it equals mass of solute divided by mass of solution times 100. So 3.6 divided by 103.6 times 100 equals 3.5. So the percent mass of sodium chloride in this solution equals 3.5. Do you understand, Mariam?
Yes.
Any problem?
No.
Okay, try to move to our sheet. as this. Percent concentration. Okay, try to read, Mariam.
It calculates the concentration of solutions in percent. The percent
Yes.
concentration is calculated by two ways. Volume, percent concentration. It calculates the concentration of solution in percent according to the volume of solvent and solute.
So what is the mathematical rule of volume, percent concentration?
Volume of solute over volume of solution. Volume of solute over volume of solvent times by 100.
Yes, so the volume of solution equal, sorry, it's not so volume of solvent, it's a volume of solution, right?
Right.
The volume of solution, yes. Okay, so this is as,
Okay.
okay, this is as volume of solution. Okay, I think you will know that it's volume of solution, not solvent. Okay.
Okay.
Okay. So after that, what is the mass percent concentration?
It calculates the concentration of solutions in percent according to the mass of solvent and solute.
Right. So also mass percent, mass of solute divided by mass of solution times 100, and 8 is a rule. Okay. Because the existence of various kind of percent concentration levels are but on different product describes a percent concentration. What about molarity? What is the rule?
Number of moles.
Yes.
Molarity is the number of moles of solute dissolved in 1 liter of solvent.
Yes. So what is the measuring unit of molarity?
Mole.
Mole.
Or molar.
Mole per gram. Or molar.
Okay.
Why mole per gram? Because number of moles measured by mole. Okay. And this is volume by liter. So mole by liter. Mole by liter. Okay. Is this example?
Okay.
Example. Okay. Try to read this example.
Calculate the molar concentration of sodium chloride solution if the mass dissolved in dissolved sodium chloride equals 117 gram and the volume of water equal 320 milliliter.
Right. So first, calculate the molar concentration of sodium chloride. Needs molar concentration of sodium chloride. If the mass of dissolved sodium chloride equal 117 and the volume of water equal 320 milliliter. So first, we are going to get 1 mole of sodium chloride. 1 mole of sodium chloride equal 23 plus 35.5 equal 58.5 gram. 58.5 gram. So number of moles equal what? For number of moles equal mass of substance divided by molar mass, right?
Yes.
Mass of substance, mass of dissolved NaCl equal 117. Divided molar mass of NaCl equal 58.5. So it equals 2 mole. So first we get number of moles. Okay. According to volume of water, we must calculate volume by liter, not by milliliter. Liter, not by milliliter. So to change from milliliter to liter, we are going to make divide 1000 because liter equal 1000 milliliter, right?
Right.
So 320 milliliter equal 0.332 liter. So the molar concentration of solution equal what? equal number of moles divided by volume of solution. Number of moles equal to volume of solution equal 0.32. So finally equals what? Equals 6.25 mole. Right?
Right.
Any problem?
No.
Okay. Example number 2. Try to read.
Calculate the molarity of sugar solution C12 H22 O11 if the mass of dissolved sugar equal 85.5 gram and the volume of solution equals 0.5 liter.
Right. By the same way, try to think. Read, Mariam. Try to think.
Okay.
First, we are going to get what? What's first we are going to get it?
1 mole?
Yes, molar mass of sugar.
Yes.
Try to get it. Molar mass of sugar.
Okay, wait.
Okay, and you must take in your consideration that C equal 12, H equal 1, O equal 16, right?
Right. I will get the calculator and I'll come back.
Yeah, okay. Take your time.
Plus 22 plus it will be 342.
342. Okay, so molar mass 342, right? After molar mass, we are going to get number of moles. Number of moles equal what?
Number of moles will be mass over molar mass.
Yes, mass of substance divided by molar mass equal 85.5 divided by 342 equal what?
Yes. 0.25 mole.
Yeah, equal 0.25 mole. So we get the number, we got number of sugar moles. Okay, so molar concentration equal number of moles 0.25 divided by molar mass. Okay, volume, sorry, divided by volume of solution 0.5 equal 0.5 mole per liter. Okay, mole per liter. Do you understand, Mariam?
Yes.
Any problem?
No.
Okay. Try to answer this problem, Mariam, about molarity. Okay.
Which one?
I will say to you. Is number 3.
Number 3, find the molar.
This number 3.
Okay. Hydroxide. Molar mass. .5 mole liter.
Yes. Equal what?
2.5 mole per liter.
Right, right. First, we are going to get molar mass of sodium
The
hydroxide.
number of moles.
Yes, equal 40 gram. Then number of moles, mass of substance divided by molar mass equal 0.5. Molar concentration or molarity equal number of moles divided by volume of solution. Okay, after changing it, okay, from milliliter to liter by dividing 1000. So finally equal 2.5 gram. Yes, right, Mariam. Right. Okay. Any problem till now, Mariam?
No.
This is about molarity. Okay. And the problem about molarity. Okay. So
Okay.
try to make a revision by this video, please.
Okay.
Yes, this video.
The concentration of a solution is a measure of the number of particles of a solute, a dissolvable solid, which are in the solvent, the liquid in which the solute is dissolved. What might you say about the number of particles in a concentrated solution compared with a dilute solution? Pause, think, and continue when ready. The number of particles in a concentrated solution is greater than the number of particles found in a dilute solution. Think about when you sweeten a drink by adding sugar. The more sugar you add, the sweeter the drink tastes. We can calculate this using two formulae and accompanying formula triangles. The first way of calculating concentration is to use moles, an amount of a chemical substance, and divide it by its volume.
It's molarity. Okay, number of moles divided by volume of solution. It's the first part that's called molarity.
Here's the formula triangle for this. Most of the time, volumes are measured in cubic centimetres, so 1000 cubic centimetres is equal to 1 decimetre cubed, or 1 litre. So, how many decimetre cubed is 500 cubic centimetres? Pause, think, and continue when ready. To get the answer, you need to divide 500 cubic centimetres by 1000. So 500 cubic centimetres is the same as 0.5 decimetre cubed. Did you get it right? You can find any of these quantities by covering up the one you're looking for with your finger. For example, if you cover moles, you can find this by multiplying the concentration by the volume. This is because any two terms on the bottom of a formula triangle are always multiplied together. If you want to find the concentration, you cover this and divide the number of moles by the volume. Let's try this now. If you have 2 moles of salt and dissolve it in 2 litres of water, use the formula triangle to calculate the concentration of the salt solution. Don't forget the units. Pause, write down your working out, and continue when ready. 2 moles divided by 2 litres is equal to 1 mole per decimetre cubed. Did you get it right? And did you include your units? The second way of calculating the concentration is very similar, except sometimes we use a mass of a substance divided by volume rather than a mole of a substance. The formula is mass divided by volume and has the unit grams per decimetre cubed rather than moles per decimetre cubed. Its formula triangle looks like this. Let's try a challenge. If you know that you need a 10 gram per decimetre cubed salt solution and have to dissolve it to a volume of 250 cubic centimetres, what mass of salt will you need to dissolve? Pause and write down your working out. Don't forget that you have to convert the volume from cubic centimetres to decimetre cubed. Continue when ready. The working out is shown now. Did you get it right? In summary, there are 2 ways of calculating concentration. One involves moles, the amount of solute, the other, the mass of the solute. When calculating the concentration, both ways will involve dividing it by the volume. The formula triangle can be used to calculate any quantity by covering up the one you need to find and using a multiplication or a division as shown in the triangle.
Okay, Mariam? Do you understand this?
Okay.
Okay.
Yes.
I think that now there is no problem. And we are going to begin from molality, okay, in next session, inshallah, in next Monday. Okay, Mariam?
Okay.
Okay, Mariam. I think that we are going to finish now. Okay, and good luck, Mariam.